Okay, so part 3 of the indices videos that we are going to look at is we're going to think about first fractional powers, and then we're going to think about negative powers, and then we're going to combine them together. Okay, so I've done 6 examples at the top there. You can see that I've got 4 to the power of a half equals 2, 16 to the power of a half equals 4, and 49 to the power of a half equals 7. Okay, think about what you notice between all of those numbers. Yes, they all have a power of a half. 4 ends up being 2, 16 ends up being 4, and 49 ends up being 7. That makes me think it's something to do with square numbers. Okay, so the power of a half means the same as a square root. So the power of a half means the same as a square root. You'll notice the denominator is a 2. That's because it's the square root. If I look at the next line underneath, I've got something to the power of a third. 8 to the power of a third is 2, 64 to the power of a third is 4, and 343 to the power of a third is 7. Again, I think about what the links are. Well, 2 cubed is 8, 4 cubed is 64, and 7 cubed is 343. So the power of a third is the same as the cube root. It would be the same if the power was a quarter. That is the 4th root. That means what to the power of 4 gives me that number. The same for power of a 5th, the same for power of a 6th. Okay, so what I would like you to do, please, is have a go at pausing the video and having a go at those 6 questions. Okay, I'm just going to go through the answers now, so if you still haven't quite finished them, please ensure that you are still pausing the video. Okay, first one has 36 to the power of a half. I know if it's got a half as the power, it means square root. So I write out the square root of 36, which is 6. Same again, I've got a power of a half, which means square root. Square root of 81 is 9. If I look down at number 3, it's got a power of a third this time, so that makes me think it's the cube root. And the cube root of 27 is 3. That's because 3 times 3 is 9, 9 times 3 is 27. Same thing here, power of a third, so that means cube root. Cube root of 125 is 5. Moving down, I've got something to the power of 4, to the power of a quarter, sorry. That means something times itself times itself times itself gives you 81. That number is 3. Oops, I just wrote an 8 by accident. And then finally 16 to the power of a quarter, the 4th root of 16, which is 2, because 2 times 2 times 2 times 2 is 16. Okay, thinking about how that can become even slightly more challenging is if we think about what happens if I have 2 things in my power. So I'm going to do 3 quick examples. If you need some more guidance on those examples, then please do drop me an email and we can go through them. Okay, first one, I've got 64 to the power of 2/3. 64 to the power of 2/3. Sometimes you'll see it written in brackets, sometimes you won't see it written in brackets. The brackets are there just to say that the power is affecting everything that's there. Okay, so I've just seen on my previous example that if I have a fraction with a denominator of a 3, which I do, it means cube root. Okay, so that's what I'm going to do first. I always do the denominator before my numerator. So I do the denominator bit of the power first before I think about the numerator. So that denominator is telling me to cube root 64. So I'm going to cube root 64, but I've still got that power of 2 in the numerator, which means squared. So I'm going to cube root 64 first, and then whatever I get as my answer, I'm going to square it. Cube root of 64 is 4, and I'm being asked to square 4, which is 16. Okay, example number 2. Same thing applies. I always think about what's happening in the denominator of the power first before I think about the numerator of the power. So the denominator power is a 2. Well, if it's got a denominator power of a 2 or a denominator in the power of a 2, I'm going to square root first, and then I think about what's left. I've still got a power of 3 left, so that tells me to square root the 16 and then cube it. If I square root 16, I get 4. If I cube that, I get 64. Okay, third and final example, I'll do the denominator bit first, which is a denominator of a 3, that means cube root. I cube root 8, and I've still got that number to the power of 4 afterwards. The cube root of 8 is 2, and it's asking me to do 2 to the power of 4. 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. So they are my 3 examples. Please do go back and re-watch those on this video if you need that again. But just a reminder, you do the denominator part of the power first before the numerator. Okay, there are now 8 questions and 2 stretch questions appearing on your screen. 25 to the power of a half, 216 to the power of a third, 4 to the power of 3 over 2, and so on. And then these 2 stretch questions on the right, that is a B and not a 6 inside that bracket there. Okay, please pause the video and have a go at those 8 questions. Okay, so I'm now about to start going through those questions, so if you could please ensure that you have finished those before you restart the video. If you haven't yet, then please go back and pause it. Okay, so this reminds me of the easiest type that I first saw, that if I have a denominator of a 2 in my power, then it means square root. So I'm going to square root 25, which is 5. If I've got a denominator of a 3, then it means cube root. So I'm going to cube root 216, which is 6, because 6 times 6 times 6 is 216. Okay, moving down, this one's got a numerator of something other than 1, and it's got a denominator. So I'm going to do the denominator first. So that means I need to square root the number first, and then I cube my answer. Square root of 4 is 2. 2 cubed is 8. Moving down again, this time I've got a denominator of a 3, so I need to cube root first, and then I need to square. So the cube root of 27 is 3. 3 squared is 9. Okay, now it looks a little bit more complicated because I have a fraction, but you can see there, as I mentioned before, I've got some brackets in there, and that just reminds me that that power affects everything there. So the denominator of a 2 means I need to square root everything, so I need to square root the 25, and I need to square root the 36, 5 over 6. Same thing applies here. I've got a denominator of a 3, I always do my denominator before my numerator. Denominator of a 3 means cube root, so I need to cube root both of them. That's a 1, sorry. I need to cube root those, and then I need to square the answers. Cube root of 27 is 3, and the cube root of 125 is 5. I need to square it, so it's going to be 9 over 25. Moving down, I've got a denominator of a 3 in my power, so I need to cube root everything. That means everything at the top and the bottom. Cube root of 1 is 1, and cube root of 27 is 3, so I've got 1 over 3. My numerator was only a 1 there, so when I did the power of 1, it just gave me what my answer was. Final one, I need to cube root everything first, so I've got cube root of 1 and the cube root of 64, and that's all being squared. 1 squared, oops, sorry, and the cube root of 64 is 4. I have to square it all. 1 squared is 1, and 4 squared is 16. If you did manage to have a go at the stretch, that is quite tricky. The power of a half, same as when we looked at the examples earlier on where I had a bracket for a squared bracket and then another power. Everything on the outside is affected by this power, so I need to square root everything. I need to square root the 81, which is 9. And then I've got b to the power of 4 to the power of a half, and I would normally multiply those two powers, so I need to multiply 4 by a half, which is 2. Gives me 9b squared. Okay, looking at the second example, this tells me to cube root everything, so I need to cube root 8, which is 2. And then I've got x to the power of 12, and then I've got a third as my power on the outside. I need to multiply those two powers. 12 times a third is 4, so it's 2x to the power of 4. Okay, we're now going to introduce negative powers. If I was looking back at my flow diagram up here, where I said denominator comes before numerator, there is one little section before that where it's just the negative power. Okay, so in the order in which I apply my power operations, I always do the negative bit before I do the denominator and the numerator. So we're now going to think about what the negative power might mean. So again, I'm going to do 3 examples for you, and then I'm going to ask you to have a go at 8 questions of your own. So a negative power means find the reciprocal. Okay, so negative power means find the reciprocal. The reciprocal of 2 is a half. The reciprocal of 1 over 16 is 16, in case you can't remember that. Okay, so to find the reciprocal, if it's 2 it becomes a half, if it's 1 over 16 it becomes 16. If it's a fraction, essentially I am replacing the numerator and the denominator in the 2 different positions. I'm switching them over. Okay, so I can see that I've got a negative 3. And if I go back to my diagram at the top, I said I always do the negative bit first. If there is a denominator, I'll use it there, and then finally I do the numerator number. So the first bit I'm going to do is use the negative power to find the reciprocal of 2. The reciprocal of 2 is a half. I haven't yet used that power of a 3, so that still needs to be cubed. So I've used the negative part, there was no denominator to use, and then I've used the numerator of a 3. So I need to cube everything now. 1 cubed is 1, 2 cubed is 8, that gives me 1 over 8. So again, negative if there is one, denominator if there is one, then the numerator. I use the negative first, there wasn't a denominator, and then I use the numerator of a 3. Same thing here, I've got 7 to the power of negative 2, so the negative tells me to find the reciprocal. You'll notice on my previous example, once I've used the power to find the reciprocal, then that negative doesn't appear in my answer anymore. So first thing, find the reciprocal of 7, which is 1 over 7, and then I've still got that power of the 2 that I need to use. That tells me to square everything. 1 squared is 1, 7 squared is 49. Final one, most challenging one if you'd like to think about it in that way. I've got a fractional ready, 2/3. I've got a power of a negative 3. So the first thing is to use the negative power, which means find the reciprocal. The reciprocal of 2/3 is 3 over 2. And I've still got that power of a 3. I've got rid of the negative bit in my power because I've used the reciprocal part, but I've still got that power of a 3, so I need to cube everything. 3 cubed is 27, and 2 cubed is 8. Okay, now is your opportunity to have a go at some questions of your own. There are 8 questions now on that sheet of paper. I'd like you to pause the video and have a go, please. Okay, I'm now going to go through them, so if you haven't yet finished, please do re-pause the video. If you have finished, please then mark them. Okay, so I'm going to use the negative bit first to find the reciprocal. 1 over 11. I need to square that. So I need to do 1 squared and 11 squared, 1 over 121. Second one, I use the negative bit first to find the reciprocal, which makes that 1 over 3. I've still got the power of 3, so I still need to cube everything. 1 cubed is 1, 3 cubed is 27. Negative power, find the reciprocal, which is 1 over 10. Still got the power of 4, so I do 1 to the power of 4, which is 1, 10 to the power of 4, which is 10, 100, 1,000, 10,000. This one is a fraction, so when I find the negative power, I find the reciprocal. 7 over 6. I've still got the squared there, so I still need to square the 7 and square the 6. 49 over 36. 1/2, the reciprocal of 1/2 is 2. I've still got that power of 5, so I need to do 2 to the power of 5, which is 32. Next one down, I've got 11 over 27 to the power of negative 1, so I do the negative power first, find the reciprocal, and then that's to the power of 1. Anything to the power of 1 is just itself, so 27 to the power of 1 is 27, 11 to the power of 1 is 11. Question 7, use the reciprocal part first, the negative power, 4 over 3, and then I still got to cube everything. 4 cubed is 64, and 3 cubed is 27. Final one, that is a 4 over 5. Sorry, my handwriting was a bit appalling there. Find the reciprocal first using the negative power, which makes that 5 over 4, and I still need to cube it. 5 cubed is 125, 4 cubed is 64. Okay, final little bit of indices is thinking about tying it all together. As we've said already, the order is important. I need to do the negative bit of the power first, then the denominator of the power if it's there, and then finally the numerator of the power. So I need to keep it in that order. Each of these 3 questions has got all 3 parts in the power. It's got a negative, a denominator and a numerator, so it's tying it all together. Start with this one here. So the negative part of the power tells me to find the reciprocal. Reciprocal of 25 is 1 over 25, and I've still got the power of a half. Okay, the power of a half tells me that I need to square root everything. So I need to do the square root of 1, which is 1, and the square root of 25, which is 5. That's the first example done. The second example is 8 over 27 to the power of negative 2/3. So I do the negative bit of the power first, which means find the reciprocal. You'll notice that I still have the power of 2/3 that is left, but I've used the negative part, which is why it's disappeared from here. Okay, next thing I need to check for is the denominator of the power. The denominator of the power is a 3, so I need to cube root everything. So I need to cube root 27, I need to cube root 8, and I still need to square that answer. Cube root of 27 is 3, cube root of 8 is 2, and I still need to square it, which gives me 9 over 4. Final example, 16 over 25. Do the negative bit first, so I find the reciprocal, 25 over 16. I've still got that power of 3 over 2. Notice when I find the reciprocal, it's just the fraction that flips over, the power stays the same. Just the fraction that flips over, the power stays the same. Okay, really, really important there. This tells me to square root in the denominator, so I need to do the square root of 25, the square root of 16, and I need to cube it. 5 cubed is 125, and 4 cubed is 64. Okay, 5 questions, final 5 for you to do. Please pause the video and have a go, and I'll go through the answers shortly. Okay, if you have finished, excellent, I'm about to go through the answers. If you haven't, please do re-pause the video. Okay, so I'm going to use the negative part first, find the reciprocal. Still got the power of a half. The power of a half tells me to square root, sorry. Power of half tells me to square root, which is 3. This one, find the reciprocal. My power stays the same, except the negative bit has disappeared because I found the reciprocal. I need to square root both those numbers, so square root of 1, square root of 4, and I still need to cube that. That's 1/2 cubed. 1 cubed is 1, 2 cubed is 8. Third one, find the reciprocal first. 1 over 8, my power stays as 4 over 3. I've put brackets in there to remind me that I'm cube rooting everything next. Denominator of 3 means cube root, so I need to cube root 1, I need to cube root 8, and then I need to do them both to the power of 4. Cube root of 1 is 1, cube root of 8 is 2, that's the power of 4, 1 to the power of 4 is 1, 2 to the power of 4 is 16. Final 2 questions to go. Find the reciprocal first, and then I've got a power of a third. Notice again, the fraction flipped over, the power does not. I then do the cube root of everything, so I need to do the cube root of 8 divided by the cube root of 125, which is 2/5. Final one, find the reciprocal of this fraction, 64 over 27, and that's still to the power of 2/3. I'm now going to cube root everything. Cube root of 64, and that's all squared, sorry. So cube root of 64 is 4, cube root of 27 is 3. That will need to be squared still, 16 over 9.